We're going live. 1, 2, 3, 4. We're going live. Okay, so there is sound. There should be sound now. Sound is here. Is it? It's here now. Okay. We should have sound. So we should have, yeah, it shows, the indicator shows there is sound. No sound. Okay, now I might have been on the, but the actual, what happened was I got a call on my phone and it was connected to my headset as well. So, and after that, the computer did not start. After that, the computer did not start the microphone. Yeah, the computer, my Mac lost my microphone. So we're back to, yeah, it's to our problem, the easy. We're still playing with the easy problem. So where we were at, we created a row because we need to create each row, initialize an array for each row. Because here we just have an array. Oh, actually, it's an array of arrays. That's a type of this length. But there are no actual rows in it. So we're creating one by one. By the way, I'm not sharing. I just realized I'm not sharing. Share. Yeah, so now I'm sharing. So this creates an array of the needed length. Yeah, that's a row, and we're going to go over that row. And for each in each column, we're going to put the value from the original. And once the row is done, we'll need to say, okay, the row, that row is now that row. I'm thinking because, okay, I'm just checking that I'm not playing with the same row. Yeah, I'm creating a new slice every time and putting values in it and putting assigning to our two-dimensional slice. So this should be working now. Or unless, so it works. Unless there is unless they have a different logic for that. Yeah, it works. Yeah, so look, it works. Pretty good runtime. Memory. Why are we so small on memory? Why are we so small on memory? Memory, I don't know, but I don't know. Do I care? On memory, we have on memory. I mean, in each iteration, we're creating a new row. and new slice. We are then assigning that value to the two-dimensional. And next one, we are again creating a new slice. But that two-dimensional remembers, holds all of them. I'm not saying immediately how to optimize it, but it's not mandatory. So I think we should. So basic point one is the assumption, it looks like the assumption that the easiest, or like the simplest, that the requirements are the easiest here. So if it's not the right length, if the lengths don't match, then it's even if there is more space, it's still not right. Or we still should return an empty array. So I'm glad that assumption was right, and I'm glad that I made it, because otherwise I would have to work on this other case, which I didn't need to. So, okay, so we have that. Now, let's take a sip of water. And our proud viewer, thanks for the proud viewer who told us there was no audio after that call. So we're done with that easy one. We can move on to the reverse binary tree. Oh, geez. So I feel I need a snack. Well, let's give it another 20 minutes or so. So we're restarting. We are restarting the timer. Okay, so this is a medium level problem, and what do we know? We have a binary tree, and we have odd levels in that binary tree. So this is odd level. It reverse the node value in each odd level. For example, those nodes values at level 3. Suppose the node values at level 3 are, then it should become, okay, it looks like return the root of the reverse tree. A binary tree is perfect. All parent nodes have 2 children and all leaves are on the same level. So each parent has 2 children, lives on the same level. Good. Level of a node is the number of edges along the path between it and the root node. The level is the number of edges. Okay, wait a second. Okay, the root. So this is 1. Okay, this is 0. This is 1. That's why 3, 5, 5, 3. And we want to reverse. Okay. And it's perfect. So yeah, the depth will be the same. So we want to keep the same values on the even levels. 0, level 2, the level 1 we want to reverse them. Well, my first idea, my gut's feeling is we're talking about it breadth first. Breadth, can I pronounce it? Breadth first search. Okay. Where is the button? BFS, because we're gonna go because we're gonna be looking at them by levels. It's one approach, but I don't know how to at this point. I mean, I need to think about it. I need to think. So the thing is, we want to reverse, given the root to reverse node values. Okay, good news. They're not asking us to move the actual node. They only want us to reverse the values because the node has a memory address. And if they wanted to reverse the node, a different task. But in this case, just the values. So the nodes should be the same, or could be the same. Could be the same. They might not even care. I think that one problem I did, the system didn't care about the actual nodes. The system cared about the values. So we could be actually moving the node and then relinking it, or we could be just working with the nodes as they are. And okay, yeah, if think as we don't move the nodes, think about it like that. So there will be level 1, 0, level 1, level 2, level 3. And we need to reverse this one, right? And the most easy brute force approach would be to, I mean, if you want to reverse anything, and by the way, how many other, like, to the number in the range to the power of 14. Okay, so I think it's also something like the number of levels is about that size. The height is around that. Node val. The values are these. It's perfect. Good. Okay. Now I think we kind of read. I only read one example, but But basically, the next example, the odd levels have non-zero values. What is this telling us? The node as well, after the reversal. Non-zero explanation. Non-zero. Why do we care about non-zero? I don't think we should worry about it because it's a case-by-case thing. So it's a case, okay, so To reverse any kind of sequence, we do need to go over that sequence. The easiest way to go is to use two pointers if it's an array from left to right, and then switch from left from right and switch the values. Okay, so now we can, yeah, I can speak louder because my streaming room, I'm the only one in my streaming room now, which is the office. So we're co-working, little co-working office. So, but when we do that in a tree, when we deal with a tree, we we can only get. So how do we get those access? How do we access those these nodes? With the breadth search, we can do a queue in all of them, and those odd values and queue them, and because what happens is we'll get a queue of the current nodes, which gives us the queue of their children, which are queued after, okay, and which are queued after, and so on. Here is what I'm thinking. This could be a little bit different because check this out. We actually have two binary trees. Yeah, let's dumb it down because we have two binary trees, and starting with this row, we in this case we just switch the values. In the next row, we'll have 8 values. And we'll need to go over them. Wait a second. So in this case, we just switch. But what happens here, if it's a longer level, at this level, yeah, we need to reverse the entire thing. So it will look like one, two, let's say it's 1, 2, 3, 4, 5, 6. If I could only type, huh? Yeah, I'm looking at it in this context of two binary trees, of two subtrees. So we don't just switch. Yeah, we need to start from the right. I mean, if we look at it, if we go on the left tree and the right tree, we'll need to switch their values and also reverse their values. So this is reversed and moved here. This is reversed and moved here. Uh-huh. And copied there. So this thinking about two different binary trees, and it's going to be the same for all the other levels. For all the other levels. Mm-hmm. Yeah, this is the same for all the other levels. What, do I get notifications when I get a when I get participants, reactions, timestamps? What is timestamps? Okay, I allow timestamp moderation activity. I hope I get notified when I get when someone enters, but I don't know. So well, we have okay, I have another call.